2 episodes of theory. Now we build. In this episode, we go from an empty folder to a working MCP server that Claude Desktop can connect to and use. We install the official Python SDK, create a server, register a tool that adds two numbers together, run it over standard input-output, test it with the MCP Inspector, and then connect it to Claude Desktop and ask Claude to use it. Every server you build in this series follows the same structure we establish here. We create the project with UV, which is the package manager Anthropic recommends for MCP servers. We run UV init with the project name, change into the directory, and add the MCP package. If you prefer pip, you can install MCP directly. The entire server lives in one file called server.py. As our servers grow more complex in later episodes, we will split into multiple files. But for a first server, one file is all we need. Creating the server takes 3 imports and 1 line. We import the server class from mcp.server, the standard input-output server runner from the stdio module, and the types module, which we will use for return values. We instantiate the server with a name string. This name is what the client sees when it connects. It appears in the Claude Desktop interface and in the MCP Inspector. The server is now ready to have tools registered on it using decorator syntax. Tool registration uses 2 handlers. The first is the list tools handler decorated with app.listtools. This is called by the client to discover what tools the server exposes. We return a list of tool objects. Each tool has a name, a description, and an input schema defined as a JSON schema object. The description is what the language model reads to decide whether to call this tool. The input schema tells the model what arguments to provide and validates them before the function runs. The second handler is the call tool handler decorated with app.callTool. This receives the tool name and a dictionary of arguments whenever the model requests a tool execution. We check the name, perform the computation, and return a list of content objects. For text results, we use text content with type text and the string value. The raise at the end handles any tool name the server does not recognize. In later episodes, we will move each tool into its own function rather than using a single if block. The entry point uses async I/O and the standard input-output server context manager. The stdio server yields a read stream and a write stream connected to standard input and output. We pass these to app.run along with the initialization options. The server is now listening for JSON RPC messages on standard input and writing responses to standard output. Running Python server.py directly does nothing visible because it is waiting for a client to connect. We test it using the MCP Inspector. The MCP Inspector is an official tool for testing servers interactively. We run it with npx, passing the command to launch our server. It opens a browser interface showing the full connection lifecycle. We can see the initialize handshake, browse the tools/list response, showing our add tool and its schema, and call the tool manually by entering arguments and clicking run. The raw JSON RPC messages are visible in a panel on the side. This is the fastest way to verify a server is working correctly before connecting it to Claude. To connect the server to Claude Desktop, we edit the Claude Desktop config file. On macOS, it lives in the Application Support Claude directory. On Windows, it is in the App Data Roaming Claude directory. We add an MCP servers object with a key for our server. The command is Python and args, contains the absolute path to server.py. Restart Claude Desktop and the server will appear in the Tools panel. You can now ask Claude to add 2 numbers and it will call your tool. You now have a working MCP server. It registers a tool, handles calls, returns results, runs over standard input-output, passes MCP Inspector tests, and connects to Claude Desktop. In the next episode, we go deeper into the 3 capability types: tools, resources, and prompts. We build examples of all 3 and learn when to use each one. Subscribe so you do not miss it. See you in the next one.